Ever feel like you're just drowning in information, especially with tech stuff, like you're constantly skimming, trying to keep up, but you just wish someone would give you the shortcut, the real scoop? Well, that's exactly why we're doing the deep dive. Our whole mission is to take that really dense, complex material and pull out the core insights, the aha moments, basically give you that edge so you feel genuinely clued in without spending weeks researching. So today we are plunging into something that honestly looks like alphabet soup at first glance. LLDP and LLDP MEAD. I know, sounds maybe a bit obscure, right? But stick with us. We're diving into this fantastic technical document from Ruckus, and by the end of this, you'll see how these protocols are, well, kind of the unsung heroes of modern networks. They go from alphabet soup to basically network superheroes, quietly making everything work. So get ready. We're going to unpack what LLDP and LLDP-MED actually are, why they're so crucial for, finding devices on a network and managing them, and how they play a role in everything from just making your office phone work right to actual critical emergency services. Let's get into it. Okay, so let's start unpacking those. Imagine your network, right? Like a bustling city. You've got servers, switches acting like, I don't know, traffic intersections, IP phones everywhere, laptops, cameras, all these different devices, often from totally different makers. How do they even know who their neighbors are? How do they introduce themselves when they get plugged in?
That's precisely the problem LLDP solves.
Ah, LLDP, link layer discovery protocol.
Exactly. It's a standard, an IE 802 standard, actually. So it's foundational for most local area networks. Wired, even some wireless, uses it. It's the mechanism for those devices to say, hi, I'm here, this is who I am, and this is what I can do.
So it's like a universal introduction service for network gear.
You could put it that way. At its core, LLDP lets any device on an IE 802 network LAN or MAN broadcast its identity and capabilities.
Oh.
And, just as importantly, it lets it discover the other devices it's directly plugged into on that same segment.
Okay.
Think of it like a constant quiet chatter between adjacent devices.
How do they talk? What's the medium?
They use these small packets called LLDP data units, or LLDPDUs. And the clever part is how these packets are structured. They use something called TLVs.
TLVs, type, length, value.
Exactly. Type, length, value. Each piece of information is neatly packaged this way.
Okay. Type, length, value. That sounds, I don't know, deceptively simple. Why is that structure such a big deal? And maybe more importantly, why should you listening care if devices are having these little chats? What's the real benefit here?
Well, the simplicity of TLV is actually its genius. It makes LLDP
Oh.
incredibly flexible, extensible. Imagine, like, 5 years from now, there's a new type of network function or device. With TLVs, you just define a new type. Older devices that don't understand it, they just skip that TLV.
Ah, so they don't break.
Exactly. They ignore what they don't know. Newer devices understand it. It allows the protocol to evolve without killing backward compatibility. It's really quite elegant.
Okay, that makes sense. So the benefits for us.
Oh, they're significant. First off, simplified network management. Think about large networks, especially with gear from multiple vendors.
Yeah, that's pretty much everywhere now.
Right. LLDP cuts down massively on the manual work. No more guessing what's plugged in where, no more relying on, some spreadsheet someone forgot to update months ago.
Because they can all speak a common language, at least for introductions.
Precisely. Which leads to the second point, accurate physical network topology discovery. Your network management system can use LLDP info to automatically map out how everything is physically connected, real-time, self-updating.
Wow, okay. So instead of tracing cables for days...
It's like having a live map of your network infrastructure.
So it's not just knowing that a device is there, but what it is and where it's physically plugged in. That sounds huge just for keeping track of everything.
Absolutely. And that's the next benefit, enhanced network inventory data. Devices use LLDP to advertise their system name, maybe a description like core switch floor 3, your capabilities.
If it's a switch or a phone or an access point.
Exactly. Plus product name, model number, hardware type, even the operating system version.
That's gold for asset management. And security audits too, I bet.
Totally. Knowing exactly what's on your network is step one for security. And finally, for anyone who's ever had to troubleshoot network problems, LLDP is a lifesaver.
How so?
It helps spot common, really annoying issues super fast, like speed and duplex mismatches between two ports.
Oh, those are the worst. They can just cripple performance?
Right. LLDP flags that. It can even help find devices that have a bad IP configuration. Maybe they can't even be pinged. Turns hours of head scratching into potentially a 5-minute fix. It finds those ghosts in the machine.
Okay, so LLDP is like this incredibly detailed, always updating professional bio for every device. Huge step up from just hoping things work. But you mentioned devices like IP phones, video units, things that need more than just a basic intro, right? Where quality of service is critical.
Exactly. That's where LLDP MAD comes into play. Think of it as the next level.
MED, media endpoint device.
Correct. LLDP for media endpoint devices. It's an extension specifically defined by an ANSYS standard, and its focus is squarely on those devices common in, say, voice over IP networks, VoIP.
So like my desk phone, maybe the soft phone app on my laptop,
Yep.
conference bridges.
Yep, all of those. IP telephones, soft phones, VoIP gateways, conference bridges. Things handling real-time voice and video.
And LLDP MED gives them extra powers. What additional stuff does it bring, especially considering how finicky voice and video can be about network quality?
It adds some really crucial capabilities for those environments. First, vendor-independent management for telephony. This lets you mix and match IP phone systems from different vendors on the same network. Big deal for flexibility. Avoids getting locked into one supplier.
Okay, that's useful. What else?
Automated network policy deployment. This is massive for quality.
How does that work?
LLDP MIDI allows the network switch to automatically push down things like quality of service QoS settings and voice VLAN assignments to the phone when it connects.
Ah, so the phone immediately gets priority for its traffic and gets put in the right network segment without manual config.
Exactly. It ensures voice traffic gets the treatment it needs to avoid jitter, drops, bad call quality, automates a ton of configuration. Then, maybe the most impactful, a critical safety feature. It supports E911 emergency call services.
E911 Enhanced 911 for location.
Precisely. It enables much more accurate location identification during an emergency call from an IP phone.
Okay.
Potentially life-saving stuff. We should definitely circle back to that.
Yeah, absolutely. We need to dig into that.
It also allows for gathering enhanced endpoint inventory information, even more details than standard LLDP, specific to these media devices. And naturally, it aids in advanced network troubleshooting by helping spot if those network policies, the QoS or VLAN stuff, are misconfigured.
So it really is tailored for the specific needs of voice and video, removing headaches, boosting performance, and that E911 piece sounds incredibly important, bridging tech and, well, human safety.
It absolutely is.
Yeah.
And to handle the different types of devices, LLDP MED defines 3 classes.
Classes.
Yeah. Class 1 is basic generic devices. Think discovery, maybe a controller. Class 2 is for media endpoints that handle streams, like a gateway. But Class 3, that's for things like your IP phone, the communication endpoints. That class supports the really advanced stuff, including that E911 location ID and the detailed inventory.
Got it. So the classification helps tailor what information is exchanged based on what the device actually does. Makes sense. Okay, let's go deeper now into the actual data. We keep mentioning TLVs, type, lengths, value. What specific details are flowing back and forth? What juicy bits are in those LLDPDUs?
Right, the TLVs are the payload. Every bit of info is in one or more TLV. There are a few mandatory ones that every LLDP device has to send.
The absolute basics.
Exactly. First is the chassis ID.
Yeah.
That's a unique ID for the device itself, usually its main MSC address, like its serial number.
Okay.
Then the port ID. This identifies the specific port the message is coming from. Could be the interface name, like eFlow, or maybe the port's MAC address.
So which door the message came out of?
Kind of, yeah.
Yeah.
And third is the time to live, or TPL.
Yeah.
This tells the neighbor how long to keep this information before it assumes it's stale, usually a couple of minutes.
Right, so the info expires if the device disappears.
Correct. Those 3 are the fundamental who, from where, and for how long handshake.
But you said it gets more detailed. These organizationally specific TLVs, that sounds like where the real power lies, moving beyond just ID. It's kind of amazing how much granular data can get packed in there.
This is where the network really starts sharing intelligence. These optional, organizationally specific TLVs provide so much context. For example, under IKEY 802.1 TLVs, a switch can advertise the VLAN ID and VLAN name for a port.
Okay, so not just the port, but what logical network it belongs to.
Right. Imagine plugging in a new security camera.
Right.
The switch tells it via LLDP, you belong on VLAN 50, the security VLAN.
Mm-hmm.
And boom, the camera joins the right network segment automatically. No manual config needed. Huge for security and efficiency.
Yeah, that prevents a lot of mistakes.
Then you have ITO 2.3 TLVs, getting into the physical link details.
Nitty-gritty.
Totally. High key SMIGI Y configuration status. This tells you about auto negotiation, the current speed, the duplex mode.
Which helps catch those speed duplex mismatches we talked about.
Exactly.
Yeah.
It also includes power via MDI info that's power over Ethernet, PoE. So a device like an access point can say, I need 15 watts. And the switch can report, I can provide this much power at this priority. Critical for managing power budgets.
Smart power. Yeah.
You also get info on link aggregation if multiple ports are bundled and the maximum frame size, avoiding packet size issues.
So devices aren't just saying hi, they're handing over a full spec sheet, a resume, and a real-time status report. It creates this incredibly clear picture. And for those LLDP and MedD devices, the phones and such, there must be even more specialized TLVs.
There are. LLDP made specific TLVs build on that foundation.
Yeah.
You have network policy TLVs. These explicitly tell the endpoint device what VLAN to use, what layer 2 priority, like 8 or 2.1p bits, and what layer 3 priority DSCP value to use for its voice or video traffic.
So the network dictates the quality settings directly.
Yes, ensuring consistency. Then those crucial location identification TLVs. We need to talk more about those.
So
And finally, extended power via MDI TLVs, which give even finer control over power for endpoints compared to the standard PoE TLVs.
So it's not just I'm a phone. It's like I'm a phone, use VLAN 20, give my voice traffic high priority. I need 7 watts of fine-grained power. And oh, by the way, I'm physically located right here.
That's a perfect summary, that level of detail.
That is truly a detailed conversation, even if it's silent.
Okay, this sounds technically amazing, but let's circle back hard to the human impact. That E911 support, you said it's life-saving. How does LLDPM actually help you if you have to make that emergency call from an IP phone in a big building?
Right. This is where the tech really matters. Think about a large office, a hospital, a university campus. If you call 911 from an old analog phone, dispatch usually gets a fixed static address. But IP phones can move around.
Yeah, you might take your phone to a different desk or be hot desking.
Exactly. Just knowing the building's main address, or even just the IP address, which might cover a whole floor or department, isn't precise enough in an emergency. Seconds count. So LLDP MD provides that missing location piece.
It provides precise location information. Using those location identification TLVs we mentioned, it can be sent in different formats. Coordinate-based, latitude, longitude, altitude, very precise.
Like GPS coordinates.
Essentially, yeah. Or, more commonly inside buildings, a civic address. This isn't just the street address. It can include the street, city, state, postal code, but also building number, floor, and even room or office number.
Floor and office number, wow.
Or it might use an ECS-ALAN, an emergency location identification number, which is a special phone number that maps back to a specific location in a database.
So what does this mean for the caller?
It means when you dial 911 from that LLDP MAD-enabled IT phone, the network infrastructure automatically tells the emergency services exactly where you are. Not just the building, but floor 7, office 714.
That's incredible. That cuts down response time dramatically.
Hugely. Getting first responders to the exact spot minutes faster?
Yeah.
Well, you can imagine the difference that makes. It truly leverages the network for safety.
That precision is just...
Yeah.
Yeah, incredible. Is that location data only used for 911, or does it have other uses day to day?
That's a good question. While E911 is the most critical use, that same location data advertised via LLDP MED is also super useful for network administrators. Think about asset tracking and inventory. Knowing the precise physical location of every IP phone, every camera, even as they move, that simplifies managing thousands of devices enormously.
So it helps keep the inventory accurate in real time.
Exactly. So it's contributing to network intelligence constantly, not just waiting for an emergency.
And how do the admins actually see all this? All the neighbor info, the PoE status, the location data, they must have tools, right?
Oh, absolutely. They rely on specific commands on the switches or routers, usually show or display commands.
Can you give us an idea? What would an admin type to peek into these LLDP conversations?
Sure. Common commands would be something like show LLDP statistics. That gives you an overview, packets sent, received, any errors, maybe unrecognized TLVs, which is great for initial diagnostics.
Okay, like a health check.
Sort of. Then maybe show LLDP neighbors. That usually gives you a quick summary table.
Yeah.
For this port, here are the neighbors I see. Their main chassis ID, their port ID, maybe their system name.
The quick glance view.
Right. But for the deep dive, they'd use something like show LLDP neighbors detail, or maybe show LLDP local info to see what their device is advertising.
And that shows everything.
Pretty much everything that's being advertised. All the TLVs, capabilities, management address, the massy PHY stuff, the PoE details, demanded power, allocated power, priority, and all the LLDP MED specifics.
Mm-hmm.
The network policy, that precise location information, the extended power details.
So they get this incredibly rich, real-time view of exactly what's connected, what it needs, where it is, and how it's configured.
Exactly. It provides phenomenal visibility,
Mhm.
makes configuring things correctly, troubleshooting problems, and just generally understanding the network state so much easier and more proactive.
Uh,
It transforms the network into something that reports on itself.
wow. So we've gone from, basic introductions with LLDP, just saying hello, to these really sophisticated, specialized, even safety-critical conversations with LLDP M&D. It's really clear these aren't just background noise. They're actively building a smarter, more self-aware, more resilient network fabric.
Indeed. LLDP and LLDP-MBD are really fundamental now for building these intelligent, often self-configuring networks.
Yeah.
They cut down so much on manual work, they make troubleshooting faster, and as we really hit on, they add layers of safety with things like E911. They're the quiet enablers making our complex modern networks actually work, often without us even noticing.
Okay, so here's something to think about as we wrap up. A final thought for you. Next time you plug a device into a network port, or connect to Wi-Fi, or maybe just make a call on your office phone, take a second to consider those invisible, silent conversations happening constantly in the background, that LLDP chatter. Now imagine, what if every piece of tech around us could do that, could accurately, clearly, automatically announce exactly what it is, what it needs, maybe even where it is, to everything else around it? What new kinds of intelligence, what new levels of reliability, what automated actions could that unlock in this world that's getting more connected every single day? Just think about how these unseen communication layers like LLDT and LLDP MED are already quietly shaping your digital life, making it safer, smoother, and just better. It's pretty amazing stuff happening behind the scenes.